What is standard molar entropy in thermodynamics? Have you ever wondered what makes a substance more disordered than another? This is where the concept of standard molar entropy comes into play. Standard molar entropy is a measure of the disorder or randomness in 1 mole of a pure substance under specific conditions. These conditions usually include a pressure of 1 bar and a temperature of 298 Kelvin, which is equivalent to 25 degrees Celsius. The symbol for standard molar entropy is S with a degree symbol, and it is measured in joules per mole per Kelvin. This measurement is important because it gives us an absolute value of disorder for a substance in its standard state. This standard state is a reference point that helps scientists and engineers maintain consistency in their calculations. Now, why is entropy so significant? Entropy quantifies how energy can be distributed within a system. When we talk about standard molar entropy, we refer to the absolute value of this disorder, which is based on the third law of thermodynamics. This law tells us that the entropy of a perfect crystalline substance approaches zero as the temperature nears absolute zero, which is 0 Kelvin. However, real substances often have a small amount of residual entropy due to imperfections in their structure. Standard molar entropy values are essential for several reasons. First, they allow for the calculation of entropy changes in chemical reactions. By comparing the standard molar entropies of reactants and products, we can determine how much disorder changes during a reaction. Second, these values help predict whether a reaction will occur spontaneously. By combining the changes in entropy with changes in enthalpy, we can use the Gibbs free energy equation to assess spontaneity. Lastly, standard molar entropy helps us understand how temperature and physical states, like solid, liquid, or gas, affect the disorder of substances. For instance, gases typically have higher standard molar entropy values compared to liquids or solids. This is because gas molecules can move more freely and occupy a greater number of microstates, leading to increased disorder. In summary, standard molar entropy is a key property in thermodynamics that measures the disorder of 1 mole of a substance under standard conditions. It plays a vital role in analyzing energy transformations and spontaneity in both chemical and physical processes. Understanding this concept can provide a clearer picture of how substances behave in different environments.